So let me get out of the way. Who is talking to you? Hey, I'm Stefan. I'm from Berlin. I do some community stuff in Berlin, organize some meetups, and I work for this company that is called Contentful. So when you do some JavaScript apps and maybe you need something to hand over to not technical people so that they don't have to edit YAML files or JSON files to change some content, you may want to give Contentful a try because we offer a web app and then a set of APIs which you can work with to make content editable. And this year, really exciting, I'm organizing a conference in November about accessibility. It's a Beyond Tellerrand side event, so if you're at BTConf and you want to make the web a little bit more accessible, maybe you want to come along. And let's talk about this year. Who knows what happened 2013? React was released. And am I the only person that remembers where he or she was when React was released? No one? I remember exactly the date and where I was at work. And I was going through the office, and I just scanned the release post and was like, I'm not impressed. But to be fair, I didn't understand actually what this was. So 2 years later, I had this opinion, which was like, well, React, right, the virtual DOM. It's super fast, it's revolutionary because of the virtual DOM and JSX. In total, it's like this. Some really smart people got into a room for weeks and came up with something that I will never, ever understand. But I'm doing programming now for quite a while. Let me tell you something. And if you do programming for a while too, you know that there is no magic in code. There is never magic in code. But sometimes you hit a dead end. And then it feels like magic. And you bang your head against the wall. You don't understand what's going on, and you get frustrated. And what should you do then? Take a break. Sleep over it, drink a tea, meet some friends, get some fresh air. And this is what I do when I hit a wall, right? And what I do is I call my friend Matthias, who lives just around the corner, and get him to my place to drink a tea. So how could I do this? I could do it the imperative way, which would be, Matthias, get out of your door, to the left, go to Frankfurter Allee, right, Berlin, to Proskauer Straße, to the park, and then at the end of the park, my house is number 22. So the imperative programming paradigm uses statements that changes the program state, right? And Matthias is the program here, step by step by step. But we live in 2018, and for sending a friend to my place, what we usually do is probably the declarative approach, right? Because I'm not explaining to someone how he or she gets to my place. I say, dude, right? This is my address. Type it into Google Maps and you will be fine. So the declarative programming paradigm expresses the logic of computation without describing the control flow, right? I don't care how Matthias comes to my place, he will figure it out. I just want that he will show up at some point. And we can relate this to programming, right? So when I want to double values in an array, I could write a function that is called double, and I could think about how I could do this. So I can create a new array, iterate over the old array, double all the values, and push them in, and return the array. But then I have to define step by step by step by step. Or I go declarative and say, here, array.map, I don't care how you do it, as long as you double the values, right? And we can apply the same principles for interfaces. So here I have this beautiful button with this beautiful animation. I could define this in an imperative way, which is like grabbing the button, adding an event listener, figuring out how to toggle a class, right? Class list, and then checking, hey, what text is in there? And switch this thing. But for that, I have to know how the DOM works. I could do the same thing with declarative UI. So I just define, all right, there's a button. It has a state, depending on a Boolean, and a click handler, and then please do this and that. I don't want to deal with the internals of this. So when you see code like this is usually wrapped in something like this, right? A component. And this was 2013. When I saw this for the first time, I was like, that's not JavaScript. What is this? Which brings me to the first topic of this talk, which is code transformations. And code transformations basically consist out of 3 parts. The first thing is, you've got a JavaScript file, or some JavaScript code, and you have to parse that, which gives you this kind of tree structure. And then you have to transform it to something else, so you can add nodes, you can remove nodes, you can change them, and then you generate new JavaScript code out of that. So let's have a look at a little bit of code here. So this code, 3 lines of JavaScript, gets a date, gets a year, and then there's this template literal, which uses this year, and then it's logging this message. And I'm using the party popper a lot in my messages, right? Unfortunately, it's not supported in JavaScript, right? Colon, tada, colon doesn't work. Maybe someday it will, but who knows? So how can we transform that today? So there's BABEL, right? The big part of our ecosystem today. So how could we make this work and write our own code transformation? Well, we would have to parse the code first. And in BABEL land, there's this tool called Babylon. So let's quickly try this out. So we can require parse from Babylon. Then we've got all the code in a string. And then we can just parse it. And what we get back is this AST thing. Sounds really scary. I know. So basically, the AST is just a tree structure of the code rewrite. So when we analyze this here, we've got a program node on top, and there's a lot of meta information. But then we've got a variable declaration or expression statements. And at the end, it's not that bad. It's just the code split down into several pieces. So when we look at this little thing here, this message, this is how the AST would look like. So here we have got a variable declaration, a variable declarator, an identifier, a template literal, a template element, another identifier, and another template element. I don't know what you think about that, but I think this is super interesting. And I started looking at JavaScript code and checking how this works. And there's this tool that is called astexplorer.net. And you can just bump some code into there, and then you can analyze how BABEL works with this. I think this is super interesting. So then we can go to the second step, which is transformation. And the tool you can use for that is BABEL/traverse. And this tool uses a pattern that is called the visitor pattern. And this pattern was described in the design patterns, elements of reusable object-oriented software book. This is famous by the gang of 4. So here's how this works. So you've got this tree structure, and this pattern defines how we can visit every node in this tree. So, and there's an enter, and then there are exit events. So you can traverse down the tree and can visit every element until you leave the end, you reach the end of the certain branch, and then you're going up again. And this way you can touch all the little nodes in this AST. So how can you make this work in code? Well, you can bring in the traverse package from Babel Traverse, and then there's this traverse function that accepts an AST. So you've got the enter function there that gets the node, and now it can simply check, well, what kind of type of node is that? And does it have the tada, colon, tada, colon? If so, please replace this with the party popper. Cool. And then the last step is the generation again, which is fairly straightforward. So you've got the generate function from the Babel generator package, and then you can just call generate AST and get the code out again. So when you execute this then, you see there, this is all the code that I just showed you. So it has the 3 packages on top. It has the string with the tada and tada. Then it's parsing the thing. And here we see the traversing with the enter. So when I execute this now, we see that I have 2 party poppers. I just wrote my own Babel transformation. I think that's super nice. But actually, you don't do this by hand, right? You write a Babel plugin, right? So how hard it is to bring this into a Babel plugin? It's not really hard. So you can export a function that then defines the visitor, right? We're dealing with the visitors pattern. And then it's abstracted a little bit, so you can say, for the template element, please do this and this. If you're interested in how to write Babel plugins, there's excellent GitHub repo That's called the BABEL Handbook, written by James Kyle. So when you want to understand how our ecosystem actually works with BABEL, this is a good place to start a read. So, but why is this person telling you this, how to transform party poppers? Well, when we're dealing with the virtual DOM, we're dealing with JSX. And JSX stands for JavaScript Syntax Extensions. And it's just another transform at the end. So here we have a function that returns JSX. I'm still not sure if I like that, but this is how it's parsed, right? So we've got a return statement, we've got a JSX element, we've got JSX opening element, JSX text, and a JSX closing element. And when we now execute this, or when we transform this, this is what we get. React create element by default. This is the default result. But what if I don't want to do React? Right? There's this configuration option that is called JSX Pragma. You can put this in your Babel config or in a comment above, which means that you can define what this function call is. So in every JSX element at the end is just a function call. It's no magic. Mostly people go with H though. And we'll talk about why H in a second. So, but when you write your JSX, have you ever wondered why you had to import that, even if it's not in your source code? Well, this is what is executed later, right? It's just a function call to H, or whatever you decide to go. But where is H coming from? H is initially coming from HyperScript. And HyperScript was one of the first repositories or projects that tried to solve the issue of writing declarative UI. So let's have a look at how to write something like HyperScript. So HyperScript defines this H that accepts a few arguments. So there's a node name, attributes, and children. And then you use these arguments to create DOM nodes. So you have the node of the DOM node you want to create, right? So this can be div, span, button, whatever you want to have. So you create this element, then you iterate over all the attributes, and then you have a few children, and you check if it's a string, right? Because sometimes a button inside, a text inside a button it needs just a text node or something. And if it's another span or div, then you create a new element. And with this, when we now execute this little function with this H, with a few lines of code we just implemented, we get DOM nodes back and a declarative UI. I think that's super cool. So let's get a little bit more advanced here and add a list here, right? So a list with a few elements. This might look a little bit unfamiliar for you, so let's look just for a second at the JSX part here. Okay? So, but this transforms to this then. So how could we render now our app? Well, we've got our app. It's not yet a component, but let's see. So we've got our app function, and then we need a render function. And to make this work, we have to store a variable outside, which is current app. And then we just create a new DOM structure with a call to app with a certain state. And if there's already an app, then we replace it. If there's none, then we add it to the DOM, right? Because otherwise we would stack the UI below each other, and that's not what we want. And then we store the reference to the newly created DOM. And then we need just a little bit of state, right? 10 Rep Rebels attendees here. And then we can render the whole thing. And now we are already getting a little bit closer, right? Because when we now execute this, we've got this. Nice. That's super cool. But in a nicely declarative way. But you might have already seen it. Now we're not quite there yet. So what happens now when we change some state? Let's say we define an interval, and we add one new entry every second. So that works, right? But when I'm in Chrome, and I open the DevTools, and I enable paint flashing, what you see is that the whole thing is re-rendered all the time. That's a lot of work to do. And when you look at the PREACT documentation, what you find there is, we want to render components and have them updated only when data changes. That's where the power of vDOM diffing shines. So back to 2013. The what? I have no idea what you're talking about, man. So the vDOM is at the end a lightweight representation of the structure of the DOM tree. And this structure can be realized by recursively comparing it against the current DOM structure. And when you then go to GitHub and you type in virtual DOM, this is what you get, right? everybody reinvents the wheel because the virtual DOM is always a little bit different. So most important, or the most famous one is probably React, but then there's also PREACT, which I spend a lot of time with recently, but then there's also Inferno, and whatever is out there. I don't want to go much into which one is the best one, but I just wanted to dig into why does that actually work, and is this the thing we will do for the next few years? So to understand how virtual DOM works, we have to come back to the H function. So remember, this is what we had, right? The H function got some attributes or some arguments and was creating DOM nodes. So let's make that to the virtual DOM. And this is it. What you see here now is virtual DOM factory. So basically it's just a mapping from a few arguments to a new object. But this function now returns virtual DOM nodes. Fancy name for an object with a few properties, right? So when we now have our app function and we execute this, this is what we get, right? Our declarative UI now is just a big JavaScript object. But now we have to touch a few more things, and we need a new function, right? Because now we blew everything, and everything is broken, because we don't know yet how to handle virtual DOM nodes. So we need a new function that is called renderNode. And this function gets all the attributes that are inside of this virtual nodes. And then we have to check if it is a text node, because then we don't have to do much. And then we're kind of doing the same thing, right? We're creating the span, button, div, whatever is in there. We're iterating over the attributes. And then we're doing the same thing recursively for all the things that are inside of this big UI JavaScript object. Nicely recursive. So when we now look at the app that was rendering my UI, there's one little adjustment, and we're back to go. But now, so the result is the same, but now we've got more control and superpowers. So why is this virtual DOM so important, and why is it good, and what does it good in general? So the first thing is component rendering. So we had a look at this, right? This is not a component yet. So let's make it one. So we can change the whole thing to be a JavaScript class, and we define a constructor, and we store some state. So this state equals. And then we've got this render function that is executed with some props and some state. We will see later where this is coming from. And this is a shorter version of that to save a line. Oh god. And now, when we go into the render node function, this is what we had before, right? This thing was only able to deal with node name div, node name button. So let's adjust this a little bit and check if the node name is a string. And if it's not a string, check if it is a function, right? Classes are functions, right? And now we're entering kind of a little bit cool part in magic. I think this is super nice here. So then we initialize this new class that we just created. Then we call component.render that returns the virtual DOM with the render node, and then we store a reference of the resulting DOM in the component itself. This means that the JavaScript component holds the DOM reference, which is extremely powerful later on. But this is not working yet, so let's define a setState function. And there's actually not much code in there. So when we have our component here, we can go into this constructor and we can add the same interval and changing the state, right? So what does setState has to do? Well, it has to accept this object and assign it to the current state of the initialized object, but then it calls something like renderComponent with itself. And the renderComponent, seriously, when I understood how this works, I was like this, because that is so clean and smart. RenderComponent is just a function that accepts, this is completely working on its own. It accepts a component, then it grabs the old connected DOM nodes, it renders itself, so it calls component.render with its own props and its own state, and sets the returned DOM element to itself, and then it replaces the old one. I think this is beautiful. So components render autonomously. When you inject a component with a virtual DOM once into the DOM tree, something like this, so you've got an app, main, a sidebar, widget, and you call setState here. This thing works completely by itself. This is why you have to inject React components only once. Then the component knows what to do. So when we look at my little example, and I refactor everything, and I have this extract the list into its own component and set the interval there, what happens is that only a tiny part is re-rendering. And this means that we're already saving some work, right? So when we look here, and I again check paint flashing, you see that the headline is not re-rendering because the component itself takes care of this. So when you once inject components into the body or into the DOM, everything just works. I think that's super beautiful. The next part is smarter diffing, right? So this was the renderComponent function that accepts one component and re-renders the whole thing. So what we have here is the old DOM, right? And then we've got component.render that returns virtual DOM. So let's compare these two for a second. So we've got the DOM here and the virtual DOM. They look quite similar, right? And that is not an accident here. So when we look at this whole thing, this is still too much work. This is replacing the whole component all the time. But when I add one element, I don't have to re-render 10 other elements. I just have to add one, right? So let's start from scratch here. So what we do is we grab and create a new virtual DOM, and then we define a diff function that returns DOM, but also is a little bit smarter, and is not just replacing or rendering the whole thing. So how could we implement this diff function? So here we have it. This accepts a DOM node and a virtual node. This is what we had before. So get the new DOM and replace everything. This is not what we want to do for my list, right? So let's just add a really naive check here. And I do like, all right, is this, do these two things, the DOM node and the virtual node, do they have the same number of children? If they do nothing. If there are new kids, though, don't re-render the whole thing, but rather only append one new element. And with this really naive check in my own virtual DOM implementation, I was able to get this. It's only one piece re-rendering, right? And this is where the power comes into. So the idea is that you only touch what changed, right? And when we look at the comparison again, we can compare, all right, is it the same element? If it was a button before and it's still now a button, probably I don't have to replace it, right? Maybe I can just do something that is not as expensive. Is there a new attribute? Remove it or add it. And are the child or the children, are they still the same? So in this function, this is not really production ready, right? This is just for me to compare the lists. So what happens in production ready software there is comparing the types, comparing the attributes, comparing the children, and then optimizing the heck out of that. Last year, Jason Miller, the creator of PREACT, gave an excellent talk at JAVASCRIPT for you, and he explains the nitty-gritty details on why PREACT is faster there or not, and how he gets it really fast. But maybe we can even save some more work here, because the DOM diffing by itself maybe causes also, or needs also some work. So when we look at the component that we have right now, and inside of the state, we actually could store the previous state, right? Because we're just dealing with data here. And then we can go into the renderComponent function, and there's a lot of going on here, so let's just go over that step by step. We grab the state that it had before and store it in two variables. Then we reset the state of the component to what it was before. And then we can implement a function that is called shouldComponentUpdate, right? Who knows that one? This is a good performance gain. But now the component itself has the state of before, and we have the new state available. Which means that, for my case, the only thing that can change is that one item for the list component is added to the list. Which means I can implement shouldComponentUpdate, and I now have the old state before it is rendered, and I get the new properties as arguments in the thing. And with this, I can save even more work, which is nice. So at the end, I'm one of the people that started re-implementing virtual DOM, right? I didn't publish it. But at the end, I put it on CodePen at the end. But it was 3.75 kilobytes and was 129 lines of code. Not optimized, but still it works. And it's far away from being perfect. When you look at PREACT, for example, PREACT is 8 kilobytes, minified but not gzip. This is optimized, covering all cases, and is production ready. I could have go on and copy PREACT, but I stopped then here, right? So what benefits does the virtual DOM implementation have? So first of all, declarative UI. This is nice. Just building UIs without knowing how to do the DOM manipulation. And so you can speed up your process there a little bit. Smart and selective re-rendering. This can save a lot of work, right? Just re-render what needs to be re-rendered. And then limit the DOM operations by optimizing the heck out of the whole thing. And due to the structure we have now, you can optimize even further and maybe batch all the reads and batch all the writes. The separation of DOM and virtual DOM here gives you a lot of power to optimize the applications. So at the end, is the virtual DOM the silver bullet? I don't know. There are also new approaches already out there, like hyperHTML or lit-HTML, and these are based on template elements and template literals, which is super interesting. So, and I'm taking in the next codes the example of lit-HTML just because I think the API is a little bit easier to read than hyperHTML. So to render something with lit-HTML, you get the HTML on the render function. Then I'm defining some data, and this is my app. Right? It's the same thing. It looks almost similar to what we had with the virtual DOM and the JSX implementation. And then I can render the whole thing. So let's just have a quick look at how this actually works. So you see this tiny piece here. This is a tagged template literal. So, and the HTML here is basically just a function. Right? And this function is then called with several arguments. And you see there that it's called with an array first, which are the static parts, the li and the closing li, and then the dynamic parts, which is the Bon Jovi emoji here. Or it's a singer officially, I think. And yeah, here we've got the static parts and the dynamic parts. And then you see that you have a clear separation of the things that can change and that cannot change. And this brings us a little bit more power even, right? Because now we can differentiate between, hey, this is the tree we're dealing with, and we only have to check for differences or changes in these parts, not the static parts. And this brings a lot of new approaches that we could use to speed up how we build UIs, and a lot of new possibilities. And I think tag template literals by itself are really cool concept. If you're interested how this kind of works, this little code pen, it's just 150 lines, is a hyperHTML implementation, and I think it's a really good read, and you understand then how you could solve that. So at the end, in preparation for this talk, man, I read a lot of PREACT code. And I was close to hitting the wall, right? And I had this little person in my head that was always, you'll never get it, you have to talk about that, but you will never get it. And I had a lot of sleepless nights, and I took a lot of breaks. So Matthias was there, sometimes for beer, sometimes for tea. But at some point then, well, it made sense, right? And then I was happy, and I was relieved. And when we're developing things, or when we're dealing with a programming business, we just have to understand that to understand things, we have to wait, to learn, and to be patient. But at some point, it will be all right, because there's just no magic in code. And that's it.
Thank you.
Sitting down?
Yes, please.
I'll get another water.
That was a really excellent, incredible tutorial on how all of that works. So I won't make you pick a favorite implementation, but just talk about why are there these different implementations and what are some of the trade-offs?
Well, the biggest comparison is definitely PREACT versus React, right? React is a lot bigger. The latest benchmarks that I saw is that PREACT is a little bit faster than React, but it's also a matter of feature sets, right? This is what I showed is just a minimal implementation. React with the latest, where are we now, 16 or 17, 16? Has a lot of new features that a lot of people want, but this all comes with a cost, right? So when you just want to go with a lightweight rendering layer, like I did here, I think PREACT works completely fine. Yeah, so for me, it's at the end just look at a few benchmarks, see if you have to render 10,000 items in a list or not, and see what features are important for you, and then pick your thing.
Yeah. All right, what are some misconceptions that maybe other people have, or even that you had yourself before you took this deep dive and read a lot of PREACT?
Well, for me, it was always like that there's a lot of things going on that I will never understand, but when you're reading these kind of things, you discover these tiny, cool pieces, like the renderComponent function that I showed. And the big misconception is that you won't understand it, and that you just have to dive into it a little bit, and then it just works. And when you do this, like I did, so it was basically really conference-driven debugging of PREACT. So you will learn a lot, and reading code is always great. So yeah, misconception is that it's too hard to understand. I don't think it is. Just sit down and take your time.
And have tea.
And have tea.
Yeah, I like the take breaks tip too.
Cool.
Thank you so much.